Ever notice how you can remember exactly where you were? Like when something big happens? Like when you heard some shocking news or experienced something you totally didn't expect? It's like our brains just hit the save button when
Yeah,
something really out of the ordinary happens.
totally.
Well, get this. Researchers over at Google are working on a new AI system. It's called Titans.
Okay.
And it learns kind of the same way by zeroing in on surprising information
Interesting.
to make AI memories way more powerful. We've got their research paper right here.
Awesome.
And let me tell you, this is not your typical neural network.
Oh, it's a really cool approach they're taking. You see traditional AI systems,
Mm-hmm.
especially the ones using those attention mechanisms, they're kind of like short-term memory.
Okay.
Great for focusing on what's right in front of them,
Yeah.
but not so good at remembering stuff long-term. It's like, imagine trying to cram a whole textbook into your short-term memory.
Right.
It's just not going to work.
Total information overload. So how does Titans deal with this whole long-term memory thing? I gotta admit, I'm really intrigued by this whole surprise angle.
Well, so think of it this way. The AI is always making predictions
Okay.
as it goes through the data. Surprise, in this case, is like
Hmm.
how wrong those predictions are.
Uh-huh.
The more wrong it is,
Yeah.
the bigger the surprise, and the more the AI learns and remembers.
Yeah.
Like, if you suddenly realize you had something totally wrong,
Oh.
that tends to stick with you.
Right. Makes sense. So it's not just about remembering every single thing.
No,
It's more like focusing on the stuff that really challenges what the AI already knows.
you got it. And this is where it gets even cooler.
Okay.
They've actually built in this idea of decaying surprise.
Decaying surprise.
Yeah, so
Okay, I gotta hear more about this.
imagine you're looking at stock market data,
Okay.
and suddenly, boom, there's a crash. Nobody saw coming.
Huge surprise.
Big surprise, right? So for the AI, that's a high surprise event. At first, it might overreact.
Yeah.
But as it sees more data, that initial shock starts to fade,
Right.
and its reactions get more balanced.
Interesting.
But the memory of that crash, that's still there. It still affects how it sees future market changes.
So it's not just the immediate oh wow moment.
Right.
It's how that surprise kind of shapes how the AI sees things over time.
Exactly. It's like
Yeah.
ripples.
Yeah,
You know,
yeah.
even after the first wave calms down, you can still feel those smaller effects.
I like that.
And in machine learning, this whole decaying surprise thing, it's a lot like the idea of momentum,
Momentum. Okay.
where things that happened in the past still affect what's happening now.
I'm starting to see how this is like human memory in some ways. But let's be real, we can't remember everything. So what about forgetting?
Oh, yeah.
Does Titans do that too?
Forgetting is actually built in to make sure things run smoothly.
Okay.
As the AI sees new information,
Mm-hmm.
it slowly starts to make those older, less surprising memories less important.
So it's like decluttering your mind to
Exactly.
make room for new experiences and new information.
That's a great way to put it.
So it's not just about what you remember.
Right.
It's also about knowing what to forget.
Precisely.
And how do they actually make that forgetting happen?
They use something called weight decay.
Hmm.
Basically, the connections inside the neural network,
Okay.
the ones that represent those older memories, they get weaker over time, so they don't influence the AI's decisions as much.
So it's like a way of automatically figuring out what's most important.
Exactly. And to make sure the most relevant information is always front and center.
Pretty smart. It's like the AI is constantly fine-tuning what it knows
Mm.
based on the latest and greatest info.
You got it.
There's one more thing about the Titans setup that we should talk about. They're using a deep neural network for the memory module.
Right.
Now, I know deep neural network sounds kind of technical.
Yeah.
So can you break that down for us? What does it actually mean here?
Sure. Think of it this way. A simple memory system
Yeah.
might just be a list of facts, but a deep neural network, it's way more complex and nuanced. It lets the AI store memories in this multi-layered, interconnected way. So it's not just the basic facts, but also how those facts are connected.
Right, the relationships and patterns. So it's
But-
like the difference between remembering a phone number and having this full picture of a person in your mind
Yeah.
with all their quirks and everything.
That's a perfect analogy. That depth gives you a much richer, more contextual memory,
Right.
which is crucial when you're dealing with tasks where understanding the connections and patterns in the data is really important.
Makes sense. Now, they didn't just stop at creating this super advanced memory system.
No, they didn't.
They actually made 3 different versions of Titans.
Yeah,
Each
yes.
one has its own special way of using memory.
That's
So
right.
it's like they created this whole family of AI memory experts.
Haha, I like that.
So first up, we've got memory as a context, or MAC.
Mhm.
What's the main idea behind this one?
Imagine you're reading a news article about something happening right now.
Okay.
You're not just getting your understanding from the words on the page.
Right.
You're also using what you know about history, politics, geography,
Yeah.
all this background info to make sense of what you're reading.
Right.
And accuracy, the long-term memory, does that same thing, provides that context for the AI.
So it's like the AI is always checking what it sees right now
Uh-huh.
against this massive library of past experiences and knowledge.
You got it. And that's super useful when you've got data that has these long-range dependencies,
Okay.
where understanding the present means remembering the past.
Interesting.
Like if you're analyzing a really long speech, MSE can help the AI understand how things said earlier,
Right.
connect to arguments made later,
Yeah.
even if they're far apart in the text.
Wow. So MSE is all about adding depth and context
Yeah.
to what the AI understands. What about memory as a gate,
Okay, so with MAG,
or MAG?
the long-term memory acts as a filter. Yeah, it carefully picks which information gets to go through to the attention part of the AI.
Okay.
It's like having a really good assistant
Right.
who knows what's important and only brings you the crucial stuff.
So no distractions.
Exactly.
Mm-hmm.
MAG learns to recognize patterns in the data,
Mm-hmm.
and then it figures out what's most likely to be useful for a task,
Okay.
and then uses that knowledge to control what the AI pays attention to.
So MAG is all about prioritizing, making sure the AI doesn't get bogged down by unimportant stuff.
That's right. Especially when you've got these huge data sets, you don't want the AI getting sidetracked by details that don't really matter.
That makes a lot of sense. Streamlining everything.
Yeah.
All right, so we've got MA adding context, and MAG is the gatekeeper.
Yep.
What about our third contender? Memory as a layer, or MAL. How does that one fit in?
Well, MAL takes a different approach. It uses long-term memory as like a pre-processing step.
A pre-processing step.
Yeah, it compresses and summarizes the data before it even goes to the attention mechanism. Think of it like having someone who's really good at taking notes.
Oh, right.
They can take a super dense chapter and turn it into a few bullet points.
Gotcha.
So you get the main ideas without all the extra stuff.
So MAL is all about making the information easier to understand before the AI even really starts digging into it?
Exactly. It basically preps the data so it's easier for the attention mechanism to handle.
That's a really clever approach. I bet it's super helpful when you're working with those incredibly long sequences of data.
Yeah, definitely.
Where even with a limited window, the attention mechanism might struggle to keep up.
It can be a game changer. It really cuts down on the computational work the attention mechanism has to do, which means you can handle much bigger data sets.
So we've got these three different variations of Titans,
Right.
each one using memory in its own way. The big question is, do they actually work? Did the researchers put these designs to the test?
Oh, they definitely put them through their paces.
Ah.
And the results, pretty impressive. They tried Titans out on a whole bunch of different tasks.
Like what kind of tasks?
Language modeling, common sense reasoning,
Okay.
even things like genomics and time series forecasting. And you know what? Across the board, Titans did better than traditional transformers and modern linear recurrent models, especially when they were dealing with those really long sequences of data.
So Titans is holding its own against some of the heavy hitters in the AI world.
Yeah, and what really impressed me, those needle in a haystack tests.
Ah, yes, the classic needle in a haystack.
You know, finding that one specific piece of info buried in a mountain of data.
It's no easy feat.
Nope. And it sounds like Titans is a pro at it.
That's definitely game-changing, being able to find that one crucial piece of information.
Absolutely. It shows that Titans isn't just storing stuff. It's really understanding the information well enough to pull out what's important. And it gets even better.
Oh, okay. I'm intrigued.
When they tested on the Babylon benchmark,
All right.
which is designed to look at how well something can reason with long contexts. Titans actually beat out much bigger language models like GPT-4.
Wait, it outperformed GPT-4? We're talking about one of the most powerful AI systems out there.
Yeah, it really shows you how much potential Titans has to change how we do AI memory and long context learning. And this isn't just about language processing either.
Okay, so let's talk about the bigger picture.
Right.
We've covered how Titans works, but what does it mean for the real world?
Oh, the possibilities are huge. Take natural language processing, for example.
Right.
With Titans, we could make AI systems that can understand really long, complex conversations.
Okay.
Analyze tons of text, and even create stuff that's as good as what humans write.
So we're talking about chatbots that are way more engaging,
Exactly.
more accurate translations, maybe even AI novelists.
You got it. And that's just the beginning.
Wow. Okay, there's more.
Think about genomics. Imagine Titans helping us analyze all that DNA data to find patterns linked to diseases,
Okay.
come up with new treatments, even understand how life itself started.
That would be incredible. The possibilities for healthcare and scientific research are just mind-blowing.
And don't forget about time series analysis.
Right.
Titans could help build AI systems that predict stock market trends really accurately,
Wow.
forecast the weather better than ever before,
Okay.
even find those tiny anomalies in complex systems that could signal that something's about to go wrong.
This is starting to sound like something out of a sci-fi movie. AI systems that could potentially solve some of the world's biggest problems.
It's definitely within reach.
Uh-huh.
And as researchers keep refining architectures like Titans,
Yeah.
we're going to see even more groundbreaking applications pop up.
It's both incredibly exciting and kind of daunting to think about.
I agree.
We've talked about the technical stuff, the potential applications, even some of the bigger implications of all this progress in AI memory. But there's one big question that I keep coming back to.
I think I know what you're going to say.
How will all of this shape the future? What's it going to mean to live in a world where machines can remember, learn,
Right.
and maybe even think in ways that are just as good as us?
Yeah, those are the questions that people are going to be debating for a long time.
No doubt.
But for now, I think it's important to bring it back to our listeners.
Okay, good point.
Why should they care about all of this?
Right. What's the main takeaway from this deep dive into the world of machine memory?
I think the most important thing is that AI is getting more and more sophisticated,
Mm-hmm.
more human-like in what it can do. We're creating machines that can learn and adapt in ways that we never thought possible before.
Yeah. And memory is at the heart of it all.
Definitely.
It's not just about storing information. It's about understanding it, prioritizing it, and using it in a way that helps you learn and make decisions.
Right.
And that's true whether we're talking about humans or machines.
Yeah. We're basically seeing these two types of intelligence converging.
Yeah,
It's both fascinating and a little bit unnerving.
I agree. There's one more technical thing from the paper that I want to make sure we touch on. Persistent memory.
Okay.
Seems like it's a key part of how Titans works.
You're right. Persistent memory is really interesting.
So can you give us a quick breakdown of what it is?
Sure. So it's basically a set of learnable parameters
Okay.
that stores knowledge about the task at hand.
Mm-hmm.
And unlike short-term and long-term memory, which are constantly changing,
Right.
persistent memory stays pretty stable.
So it's like a foundation of knowledge
Right, that's
that
right,
the
yeah.
AI system can always draw upon.
It's like knowing the basic rules of a game
Okay.
or the core principles of a scientific theory. Essential stuff,
Hmm.
but it doesn't need constant updating.
That makes sense.
Yeah.
So how does this persistent memory work with the short-term and long-term memory modules in Titans?
Well, they actually added it to the beginning of the data sequence.
Interesting.
So it's the first thing the AI sees.
Oh, that's smart. Like priming the pump with essential background information.
Exactly. And it has a couple of big advantages.
Okay, all ears.
First, it gives the AI a really reliable source of information about the task.
Yeah.
This is super helpful when the data is noisy or incomplete, because the AI can use this persistent memory as a guide.
So it's like having a trusted guide when you're exploring uncharted territory.
Perfect analogy.
Hmm.
Second, and maybe even more importantly, persistent memory helps fix a potential problem with attention mechanisms.
Okay. A problem. What kind of problem?
Well, attention mechanisms have this tendency to pay more attention to what they see first.
Mm-hmm.
It's kind of like the first impression effect.
Uh-huh.
We usually remember the first things we see or hear more clearly.
Right.
It's like a bias almost.
Okay.
The AI might think something's more important just because it's at the beginning of the sequence.
Even though it might not be the most important thing in the long run?
Exactly.
So how does persistent memory solve this problem?
By putting it at the beginning,
Right.
it basically acts like a distraction.
Okay.
Pulls the attention mechanism away from those potentially misleading first impressions.
Clever. Throwing a decoy to steer the AI toward the stuff that really matters.
You got it. It helps make sure the learning process is more balanced and accurate.
That's fascinating. So persistent memory isn't just some technical trick. It's actually a crucial part of how Titans works. It helps the AI be more reliable and less biased in how it processes information.
Absolutely.
Yeah.
It's another example of how well thought out this whole system is.
This has been a truly mind-blowing deep dive into the world of AI memory.
We've just scratched the surface, but I think we've covered a lot.
Definitely. And to make sure our listeners can keep exploring, we'll include links to the research paper and other resources in the show notes.
Good idea.
Okay, we've talked about the technical side, the potential applications, even some of the broader implications of all these advancements in AI memory.
Mm-hmm.
But there's one big question that I think is still out there.
I think I know where you're going with this.
How is all of this going to affect our future? What's it going to be like to live in a world where machines can remember, learn,
Yeah.
maybe even think on par with humans?
Those are the questions that are going to be debated for years and years to come.
Yeah.
But for now, why don't we each offer a final thought? A question that might make our listeners think a little deeper.
I like that. A question to leave them pondering.
Okay, so here's mine. As AI systems keep getting better and more integrated into our lives,
Yeah.
it's really important that we think about how memory shapes their behavior and their decisions.
It's true. Their memories, their experiences, their knowledge will definitely play a role in what they do.
Right, so the question is, how will that change the world?
That's a really profound question, one that we should all be thinking about. My final thought is a bit more personal.
Okay.
Seeing all these incredible advances in machine intelligence, it makes me wonder, what does it even mean to be human in an age of thinking machines?
A big one.
Are we just biological computers, or is there something more to us, something that makes us different from the algorithms and the data?
That's a question that philosophers and scientists have been trying to answer for centuries.
Right.
And it's even more relevant now with AI becoming so advanced.
It really is.
Yeah.
And I don't think there's a simple answer. Maybe it's the very act of asking these questions, of trying to understand the unknown.
Right.
That's what makes us human.
I like that. It's the curiosity, the drive to learn more that pushes us forward.
Exactly. So on that note of intellectual curiosity and wonder, we'll wrap up this episode of The Deep Dive.
That's good.
We hope you enjoyed exploring the fascinating world of AI memory with us today.
It's been a pleasure. It's like having this super efficient note taker,
Right.
They take this crazy dense textbook chapter and turn it into just a few bullet points.
Makes it way easier to digest.
Exactly.
So Mal is basically simplifying things before the AI even starts trying to understand it in depth.
That's it.
Makes sense, especially with those mega long sequences of data.
Oh, yeah?
Even a limited window attention mechanism might have trouble keeping up,
Right.
but this way it's prepped and ready to go.
It's like clearing the path for the attention mechanism. Makes things so much smoother.
So we've got these 3 distinct flavors of Titans,
Right.
each one with its own way of handling memory. But the real test is, do they actually work?
Yeah, that's the key question.
Did the researchers put them through their paces?
They did. And the results were pretty amazing. They tested Titans on all sorts of tasks.
Like what?
Language modeling, common sense reasoning,
Okay.
even things like genomics and time series forecasting.
Wow, so all over the map.
Yeah, and get this across the board. Titans was consistently outperforming traditional transformers and modern linear recurrent models, especially when it came to those really long sequences of data.
So Titans is holding its own against some of the big names in the AI world.
Oh, yeah. And what really stood out to me, those needle in a haystack tests.
Ah, yes. The classic needle in a haystack.
Finding that one little piece of information buried in a ton of data.
Right.
That's where Titans really shines.
And that's a big deal. Being able to pinpoint that one crucial piece of information is a game changer.
Absolutely.
Yeah.
It shows that Titans isn't just remembering stuff. It's actually understanding it deeply enough to extract what's important.
Okay.
And get this, when they tested it on the Babylon benchmark, which is specifically designed to look at long context reasoning,
Right.
Titans actually did better than much bigger language models,
Like
GPT-4.
wow. Outperforming GPT-4, that's a huge accomplishment. I mean, GPT-4 is considered one of the most powerful AI systems out there.
It really highlights the potential of Titans to revolutionize how we approach AI memory and long context learning. And this isn't just limited to language processing.
Okay, so let's zoom out a bit.
Right.
We've talked about how Titans works, but what does this mean for the real world? What are some of the potential applications?
Oh, the possibilities are vast. Take natural language processing, for instance.
Okay.
With Titans, we could create AI systems that can understand these really long, complex conversations, analyze massive amounts of text, even generate creative content that's as good as what humans can write.
So think more engaging chatbots, more accurate translations, maybe even AI novelists.
Exactly. But it goes beyond that. Imagine Titans helping us analyze huge amounts of DNA data in genomics.
Right.
To find patterns related to diseases, develop new therapies.
Wow.
Even understand the origins of life itself.
The potential impact on healthcare and scientific research is incredible.
And then there's time series analysis. Titans could be used to build AI systems that can accurately predict stock market trends.
Okay.
forecast weather patterns with amazing precision,
Yeah.
even detect those subtle anomalies in complex systems that might indicate a problem's about to happen.
This is starting to sound like something out of a sci-fi movie AI systems that could potentially solve some of the world's most challenging problems.
It's definitely within the realm of possibility. And as researchers continue to refine architectures like Titans, we can expect to see even more groundbreaking applications emerge.
It's both exciting and a little bit daunting to think about all the possibilities.
Absolutely. But let's bring it back to our listeners for a moment.
Okay, good idea.
Why should they care about all of this?
Yeah.
What's the key takeaway from this deep dive into the world of machine memory?
I think the most important takeaway is that AI is becoming increasingly sophisticated and human-like in its abilities. We're building machines that can learn and adapt in ways that were once thought to be impossible.
And memory is at the heart of that progress. It's not just about storing information. It's about understanding it, prioritizing it, and using it in a way that supports learning and decision-making.
And that applies to both human and machine intelligence. We're essentially seeing these two forms of intelligence converging, which is both fascinating and a little unsettling.
It definitely raises some interesting questions about the future of humanity and our relationship with technology.
Okay, before we get too philosophical, there's one more technical detail from the paper I wanted to touch on. Persistent memory.
Right.
It seems to play a key role in the Titans architecture.
You're right. Persistent memory is fascinating. It's basically a set of learnable parameters that store knowledge about the specific task. And unlike short-term and long-term memory, which are dynamic and always changing, persistent memory remains relatively stable.
So it's like a foundation of knowledge that the AI system can always rely on.
Exactly. It's like knowing the basic rules of a game or the fundamental principles of a scientific theory, essential for understanding the data, but not something that needs to be constantly updated.
That makes sense. So in Titans, how does this persistent memory interact with the short-term and long-term memory modules?
It's integrated in a really clever way. The persistent memory is actually added to the beginning of the data sequence. So it's the very first thing the AI system sees.
Interesting. So it's like priming the pump with essential background information before the AI even starts processing the main data stream.
Exactly. It ensures that the AI system has the necessary foundation to understand and interpret the incoming data. And this has a couple of benefits.
I'm all ears. Tell me more about those benefits.
Well, first, it provides a stable and reliable source of knowledge about the task. This is really helpful when you're dealing with noisy or incomplete data, because the AI can rely on this persistent memory to guide its understanding.
So it's like having a trusted guide who can help you navigate through a confusing or unfamiliar landscape.
That's a great analogy. Second, and perhaps even more importantly, persistent memory helps to address a potential issue that can arise with attention mechanisms.
Okay, what kind of issue?
Well, attention mechanisms have this inherent tendency to pay more attention to the information they encounter first. It's like the first impression effect. We often remember the first things we see or hear more vividly.
So it's a form of bias. The AI might overemphasize the importance of information simply because it appeared early in the sequence.
Exactly. And this can be problematic because those initial pieces of information might not actually be the most relevant or informative in the long run.
So how does persistent memory help to solve this problem?
By placing the persistent memory at the beginning of the sequence, it essentially acts as a distraction, diverting the attention mechanism away from those potentially misleading first impressions.
Clever. It's like throwing a decoy to redirect the AI's attention to the information that truly matters.
That's a good way to think about it.
Yep.
It helps to ensure more balanced and accurate learning, especially when you're dealing with long and complex data sequences.
So persistent memory isn't just a technical trick. It's a fundamental component of the Titans architecture, helping to make the AI system more reliable and unbiased in its processing.
Precisely. It's another example of how thoughtfully designed this system is.
This has been a truly fascinating deep dive into the world of AI memory.
We've barely scratched the surface, but I think we've covered a lot of ground.
We have. And to make sure our listeners can continue exploring this topic, we'll include links to the original research paper and other resources in the show notes.
Always a good idea.
Okay, we've talked about the technical details, the potential applications, even some of the broader implications of these advancements in AI memory. But there's one big question that still lingers.
I know where you're going with this. What does it all mean?
Exactly. How will these advancements shape our future? What does it mean to live in a world where machines can remember, learn, and perhaps even think in ways that rival our own?
Those are questions that will likely be debated for years to come. But for now, let's each offer a final thought, a question that might spark further reflection among our listeners.
I like that. A question to leave them pondering.
Here's mine. As AI systems continue to evolve and become more integrated into our lives, it's crucial that we consider the role of memory in shaping their behavior and decision-making. Their memories, their experiences, their knowledge will inevitably influence the choices they make. So the question is, how will this impact our world?
That's a profound question, and one that we should all be thinking about. My final thought is a bit more personal. As we witness these incredible advances in machine intelligence, I can't help but wonder, what does it mean to be human in an age of thinking machines? Are we simply biological computers, or is there something more to our existence, something that sets us apart from the algorithms and the data streams?
That's a question that philosophers and scientists have been grappling with for centuries, and it's only become more relevant with the rise of AI.
Indeed. And I don't think there's a simple answer. Perhaps it's the very act of asking these questions, of grappling with the unknown, that defines our humanity.
I like that perspective. It's the curiosity, the quest for understanding that drives us forward.
Exactly. Well, on that note of intellectual curiosity and open-ended exploration, we'll bring this episode of the Duck Dive to a close. It's pretty amazing to think about how this research is changing what AI can do.
Yeah, it really is groundbreaking. This whole idea that AI systems could actually have this really sophisticated memory, being able to learn and reason in ways we never thought possible. It's both exciting and a little bit mind-blowing.
I totally agree. And when you think about all the potential uses, it's clear that this technology could have a huge impact on so many different areas.
Absolutely. From natural language processing and genomics to time series analysis and beyond, the possibilities are pretty much endless.
We've already talked about some of those applications, but let's dive a little deeper into one area where Titans really seems to excel: those needle in a haystack tests.
Ah, yes, the classic needle in a haystack challenge. Finding that one crucial piece of information buried in a mountain of data. It's a testament to how powerful and precise this new approach to AI memory is.
The fact that Titans outperformed even these massive language models on those tasks is incredible. What was it about this architecture that made it so good at that?
Well, remember how we talked about those 3 different flavors of Titans? ME, Mag, and Mal. Each one has its own strengths and weaknesses. But when it comes to those needle in a haystack challenges, it seems that MSC, or memory as context, really takes the cake.
So the version where long-term memory provides that extra layer of background information really helps the attention module focus on the important stuff.
Exactly. It's like having a detective with a photographic memory, able to remember every detail and connect the dots in ways that a regular person just couldn't.
That's a great analogy. So MS is using the combined power of both short-term and long-term memory
Right.
to achieve a level of accuracy and efficiency that we haven't really seen before.
Exactly. And this highlights a really important point about developing AI. It's not always about making these bigger, more complex models.
Yeah.
Sometimes the key is designing architectures that cleverly combine different components and let them work together more effectively.
It's about finding that sweet spot between power and efficiency.
You got it. And Titans is a perfect example of how smart design can lead to big leaps forward in AI capabilities.
Now, as we wrap up our exploration of Titans, I think it's important to remember that while this technology holds a lot of promise, it's not without its challenges. There are still technical and societal hurdles to overcome.
That's a really important point. Like with any powerful new technology, we need to approach its development and use with caution and careful consideration.
Absolutely. And as AI systems like Titans keep evolving, we need to have open and honest discussions about their potential impact on our world.
I couldn't agree more. We need to think about the ethical implications, the potential risks, and how we can make sure these technologies are used for good.
These are tough issues with no easy answers, but I think that by being transparent, collaborating, and focusing on responsible innovation, we can navigate this new territory and use the power of AI to benefit everyone.
Well said. And maybe through this journey of exploration and discovery, we'll understand not only AI better, but also ourselves.
That's a great thought. And on that note of intellectual curiosity and the sense of wonder, we'll wrap up this episode of The Deep Dive. We hope you enjoyed exploring the world of AI memory with us.
Until next time, keep asking those questions, keep learning, and keep diving deep.